Hi, everybody. Great to see you all this morning. Thanks for coming, and thanks for spending some time with our session. My name is Richard Halkett. I'm the Chief Customer Officer at SambaNova Systems, and I want to be introducing our head of NLP, ML, Urmish Thakker, in just a moment. So who is SambaNova? We're a full-stack AA provider. We build chips all the way through system software, full systems, and then into foundation models, and then providing APIs, model management, and the rest of the systems you need to bring this to life, all in one stack in a single place. We're going to be talking about case studies in enterprise LLM adoption, and then going beyond individual models. And I think you'll see a great commonality between what we're going to speak about and what you heard in the previous presentation around mixtures of experts. So this is our view. We believe we're moving from this phase right now, and if you're engaged with a lot of enterprise customers, you'll find a lot of experimentation and exploration going on. We're seeing relatively few engaged in high-scale production, but we're beginning to see that change. And it's happening across every function, in every business, in every industry, and it's happening right now. It took enterprises quite a long time to get themselves in gear after the surprise of ChatGPT last year, particularly during what felt like an economic downturn in everywhere other than AI during that time. So that change is happening right now. And last week, a number of you may be aware of this, we announced a new version of our software based on a new chip, our 4th generation SN40L chip, which provides capability to deliver up to 5 trillion parameter models with 256K sequence length. You'll also hear about our composition of experts model architecture, which relates to the mixture of experts you heard before, but provides a modular kind of plug-and-play approach to that Urmish will get into, and then delivers tremendously greater performance in a way that we're finding that enterprises understand. They expect to see multiple expert models that reflect their own lines of business, and being able to provide that and then train and inference it efficiently is extremely powerful. So that's what we're offering to the market right now, and that's what we launched last week. So have a look at it on our website or on social media. It's pretty much everywhere right now. And without further ado, I'll hand over to Urmish. Urmish.
Good morning, everyone, and thank you for being here. I'll just test this out first. Nope. Okay. Oh, okay, sorry, my bad. All right. You can build large language models, but you cannot solve all these technical issues that easily. All right, thank you for bearing with me. So the first part of the talk, I'll be covering some of the case studies around enterprise LLM adoption and some of the journeys that we have seen our enterprise customers take and some of the issues that they have faced. So a lot of our enterprise customers come to us because of the full stack solution that we provide. The hardware that we build and the full stack solution that we provide creates a unique trading advantage that appeals to them. But when they come to us, they also require us to use open source LLMs. Now, proprietary LLMs or closed source LLMs are really appealing in terms of the capabilities that they provide. But there are a lot of security issues around these models that make it hard for enterprise companies to adopt them. There are issues around model ownership. What do you do with the weights after fine-tuning them? There are issues around what's happening behind the API. And there are issues around how you can actually poke them and understand what's happening within those models. Open source LLMs with their open access and open science approach allows you to understand what's actually gone into the data that have been that have been used to train those models, and sort of allows you to own the model in any way you want. And all of these challenges that I talked about previously go away. But the problem there is that open source LLMs do lag behind proprietary LLMs for some of the capabilities that our customers want. So this particular part of the presentation talks about 2 such capabilities that we have worked with our customers to solve. And then you can go to our HuggingFace page and search for SambaNova Systems and look at all the other models that we have created, where we have tried to bridge the gap between open source LLMs and closed source or proprietary LLMs. So this first case study was around building a multilingual chatbot. This was an enterprise customer that spanned multiple geographic locations and wanted to build a chatbot that sort of reflected the languages spoken across these geographic locations. When we poked around in the open source community, what we found is that either we had English chatbots or we had pre-trained multilingual models, but that were not chat-aligned and ready to be deployed. So what we did is that we started with the BLOOM 176B open source model. We went to the usual instruction tuning and alignment phase using human feedback and created a multilingual chatbot model for them to use. Before using this model, we went through the usual A/B testing to understand the win rates and how this model performs qualitatively and quantitatively. And what we ended up realizing is that what we created as a multilingual chatbot was quite exciting. Now, it doesn't beat GPT-4, but the win rates that we were seeing and the use cases that we were seeing, we realized this was good enough to be deployed in those enterprise, in the enterprise deployment scenario that we were talking about. And our customers agreed and adopted this particular model. Eventually, we ended up releasing this model also to the open source community. And again, you go to the HuggingFace website, search for SambaNova Systems, you can see this model there. And this was really, really well received everywhere within the open source communities. I had a lot of ML researchers reach out to me who were experimenting with the model and really excited about what it had to offer. The second case studies is around building LLM agents, or as we say, teaching LLMs to use software APIs. Now, once ChatGPT came out, we had this entire work around ChatGPT plugins. ChatGPT plugins were exciting because it allowed LLMs to access the world outside its confines and to turn into a real productivity tools for a lot of employees. This excited some of our enterprise customers, and they wanted to bring these capabilities in-house, but again with the same caveats that it has to be on an open source LLMs. When they started experimenting with open source LLMs to bring these capabilities in-house, what they realized is that they were struggling to get the same levels of accuracy that GPT had achieved. So they pinged us about, so they reached out to us to understand what we can do to solve this problem. We started inspecting this problem, and what we realized is that the first biggest problem that we faced is there is no way to benchmark how models do on software API manipulation. So the research team at SambaNova created a benchmark suite, took all the open source models that were available, benchmarked this on the benchmark suite, tried to understand what kind of open source models work, what kind of open source models do not work, what kind of training data is required to make this work, and then sort of looked at all the errors made, categorized those errors, and came up with very simple but effective approaches to solve that particular gap. These approaches that we came up with, we were very cognizant of the fact that some of our enterprise customers don't have a huge data science or ML talent pool, so these approaches need to be very simple and quick to use. And the approaches that we were able to suggest required a developer with a couple of hours of time to sort of augment the LLMs in a way that they can plug the gap between proprietary models and open source models. And you can see that in the table that you see below. The top half of the table talks about the accuracy in terms of what does it mean to run these open source LLMs in this particular scenario, and the bottom half talks about what does it mean to run these LLMs with the enhancements that we sort of propose. And you can see the gap between GPT and open source models was reduced significantly. Again, all of this work is available on HuggingFace and archive for you to read and use. So these are just some of the snapshots of the kind of work that we have done with our customers to reduce the gap between open source LLMs and proprietary LLMs. Now, as some of these enterprise customers became more and more mature, they started pushing these models towards production to enable all of their own internal employees to become more productive. And once they started doing that, we started seeing some unique trends that actually resonate very well with the previous speaker and what they had to say. But those unique trends led to requirements of unique system architectures that we had to go and solve for. So let's talk about the unique trends. One interesting thing that we noticed was a lot of our enterprise customers were pushing more and more towards specialized GPT models. And it was not just our enterprise customers that were pushing for it. If you look at the research literature, this is just some things that I was able to Google quickly in a couple of minutes. And you see that even the research community agrees there is a need for specialization. So what creates this need for specialization and why our enterprise customers were searching or pushing for this specialization? So as we sort of dissected the literature and talked to more and more customers about how they were using the LLMs that they were deploying on our stack, we realized we were able to roughly categorize the need for specialization across 5 different categories. The first category was they were trying to use a GPT or an open source LLM to solve a very specialized task. It might be a product portfolio explorer for a manufacturing company that has 10,000s of parts that you need to understand and sort of understand the nuances between. It can be as simple as the software API manipulation work that I talked about. It might be specialization for a niche language that they operate in and need help with. The use cases for specializations can be plenty, and as the more complex the organization was, the more need for specialization that we saw within them. The second reason for specialization can be domain expertise. Again, your GPT model was trained on English language domain. Your enterprise customer might be operating in a manufacturing domain. How do you solve that? They might be operating in a chemical domain, oil and gas. There are a lot of domains out there, and sometimes the models that you use have not seen that domain data, so you really need to go through that domain adaptation phase. Sometimes the fine-tuning is for as simple a reason as context distillation. Your system prompt was too long. Each of your input query inference takes a lot of time. You context distill it to create the same model, but that can operate at a smaller input length. And that gives you faster inference time, things that matter during deployment. The next reason specialization can matter was around robustness. Zero-shot and few-shot learning is interesting, but also can be a little flaky. You want to make it more robust. When you go from proof of concepts to productionization, you fine-tune the model so that you don't run into the issues around prompt engineering that you would have run into during proof of concepts. And lastly, the last reason that people want to incorporate, to sort of want to do specialization, to incorporate their own private data. So what we observed is that the number of expert models that these enterprise organizations had kept on increasing the more they reached a maturation stage where they were, and the more they reached a certain maturation stage where they understand where GPT models can help them within their business need and help them with the productivity needs, and the more they sort of got used to the tool and the more adoption that they did. And you can see this turns into a huge problem. If you're talking about 70B experts and if you're talking about 15 experts, you're talking about 1 trillion parameters across these experts. And to be honest, 15 is a very small number. The more complex an enterprise organization is, the more geographic locations it spans, the more complex its product portfolio is, the more market it sort of spans, the more number of experts it has to create, right? So we started sort of looking into this problem that we had not previously thought about was how do we serve trillions of parameters at scale, right? We talked about training, and when these enterprise customers became deployment ready, this is the next problem that was sort of tasked to that we faced as a company. To understand this problem, we wanted to understand what happens when you're serving trillions of parameters at scale. You understand what happens, and then you can build a system around that. So if you think about a user journey within an enterprise customer, which is serving all of these experts, you can break it down into 3 steps. In step 1, the user provides an input query. Now, this input query is broken down into subtasks depending on the experts available within the enterprise community. These breakage into subtasks can be using more explicit methods, using a lookup table. It can be using more complex methods like embedding or an ML router that using, say, chain of thought, can take a task and break it down into subtasks and map it to the right expert. Once you know what expert is needed to serve that particular query, you need to load these experts quickly. And once you have loaded these experts, you need to execute on these experts and combine them via either model merging methods, where we're doing weighted averaging, or by a simple chaining methods using your favorite library to do API chaining. Now let's look at what does this mean from a system point of view. We talked about the user journey. We talked about what is happening during this user journey. Let's talk a bit about what is needed from a systems point of view. Step 1 requires you to have a large and fast access memory to store all the experts so that you can avoid the cold server issues that our previous speaker talked about, right? You need these experts hot and loaded, ready to go. Step 2 requires you to have extremely high bandwidth so that you can load the experts that you have determined is needed for this particular input query. And step 3, you have already taken up some amount of time to do step 1 and step 2. Step 3, you have to quickly process that particular query so that you can return that particular output to your user and reduce the latency that they are seeing. So if you think about it, this kind of an architecture requires you to have a 3-tiered memory architecture. And that's where the new system that we have developed is extremely useful. If we do an ISO throughput or an ISO latency comparison, the new system that we have developed reduces the total cost of ownership by a factor of 28x when compared to DGX H100 systems in serving all of these multiple composition of experts to your users in the enterprise deployment scenario. All right, thank you everyone for bearing with us and bearing with all the hassles. If you enjoyed this talk and have questions, we have a booth set up downstairs. Please do come out. If you find this work exciting, we are hiring across all levels, across all departments. We'll be happy to talk to you and find you the right home within SambaNova Systems. And hopefully you can contribute to this journey. Thank you.